Yeah, good morning to one and all. This is Nagajyoti, working as an assistant professor in Department of ECE in St. Peter's Engineering College. So, in this session, I want to give an introduction for network topology for the course of network analysis and transmission lines. So, here, before going further, network topology, first we should know what is the prerequisite for this course. So in case of your first year, you have studied a subject of basic electrical engineering, that is BEE subject, in which you have studied about different types of components, that is active elements and passive elements. What is meant by an active element? What is meant by a passive element? Different theorems, that is superposition theorem, Norton's and Thevenin's theorems. Similarly, you have studied about how to find out a loop voltages and loop currents in a network by using a KVL, Kirchhoff's voltage law, and Kirchhoff's current law. Here, in this network analysis and transmission lines, the first unit deals with two different parts. That is, the first part deals with network topology, the second part deals with dot convention, self inductances, and mutual inductances. So, before going further, network topology, now let us see the basics which we have studied in the first year. Just will recap the elements. So in case of that is in, if I am saying it as an active element, that is active elements which will generate, which will give some power, which will generate some sort of energy, is nothing but called as an active sources or active elements. Similarly, which will dissipate the energy or which will store the energy are nothing but called as a passive elements. So the examples for the active elements are voltage source and current sources. Similarly, the examples for the passive elements are resistors. The functionality of a resistor is which will oppose the flow of current, or in simple words, we can say that it is an element which will dissipate the energy in the form of heat. Similarly, the example for the next passive element is a capacitor and an inductor. Capacitor and inductors both are examples of passive elements which will store the energy. So, if the storage of an energy is in the form of an electric field or an electric charge, then it is called as a capacitor. If it is storing the energy in the form of a magnetic field, then it is called as an inductor. So, in the complete first year course, we have studied about the importance of these elements and how to find out the voltages and currents by using KVL and KCL. But here, coming to our topic, that is, in this session, I am going to discuss about what is meant by a network topology and what are the basic definitions of network topology. So here, before going for the network topology, first we should know what is a need for studying this network topology, or what is meant by a network topology. So before going for the network topology, first we should know what is meant by a network. So a combination of elements is called as a network. So in case of a network, we'll be having elements more than 2 or 3 elements, then it is called as a network. Representation of a network in a graphical manner is called as a topology. So in case of the BEE, we are giving more important towards the type of the element which we are using. Means how to write down the expression if the corresponding element is a resistor or if the corresponding element is a capacitor. But whereas in case of a network topology, we are least bothered about the physical element present in the network, but we are giving more important rather than giving for the physical element. We are representing, we are replacing all the physical elements with other terminologies like node, branch. So here, what is the need for studying this network topology? So basically, the network topology, it is an arrangement of various elements. So here various elements itself indicates either it may be a node or it may be a link. So arrangement of various elements like nodes, links of an electrical system such that we are representing the complete, we are not dealing with the physical elements, but we are dealing with that of the type in which they have connected. Means we are interested in geometrical pattern of the elements rather than the physical elements present in the structure. So here the complete network topology deals with the elements like links and nodes. So here this deals with links, nodes and branches. And here we are not dealing with whether it is having a resistor element or a capacitor element or an inductor element. But we are interested in terms of a geometrical structure of that network. That is, we are giving importance how that network is connected. Coming to that, where we are using this network topologies. So here the network topology is used where we are dealing with complicated circuits. So whenever a circuit is having more than 3 or 4 or closed loop circuits, if I want to find out the loop currents and voltages in that corresponding network, then we are going for the network topology. So here the concepts which we have studied, that is KVL and KCL or mesh and nodal analysis, are used in order to find out unknown voltages and unknown currents if the corresponding network is smaller in size. So if the corresponding network is complicated, means if you are having a network more than that of the 3 or 4 closed loop paths, then it is time taking process and it is difficult to find out the loop currents and voltages. So in such cases, instead of using this mesh and nodal analysis, we are replacing this complete circuit with a concept of graph theory or a network topology. So here graph theory or a network topology deals with representation of all the active and passive elements in a geometrical manner. Means we are interested only in terms of the geometrical pattern of the network rather than what is the physical structure of this network. Coming to the basic definitions of a network topology, the different definitions which are which are present in case of a network topology or node, branch. What is meant by a graph? What is meant by a tree? So let us discuss these basic definitions of a network topology. So the basic definitions are node, branch, graph, subgraph, loop, tree, co-tree, mix. The last one is links or chords. So in this basic definitions of a network topology, we are going to see what are these basic things which are there in case of a network topology. So here, before going for these individual, first I am directly drawing circuit. So what is the difference between a network and a circuit is, in case of a circuit, definitely there should be a closed path. But in case of a network, it may or may not consist of a closed path. So here, just I'll be taking a circuit. That electrical circuit need to be replaced with a graph. So here, there are some steps how to convert an electrical circuit into a graph. So let me take an example of an electrical circuit. So here I am assuming that an electrical circuit, this is a resistor R1, inductor L1, capacitor C1, resistor R2 and the current source, and this is a voltage source. So here, this is an electrical circuit in which it consists of active elements followed by a passive element. So here, the active elements are voltage sources and a current source, and the passive elements are resistors, inductors and capacitors. So if we want to convert this electrical circuit into a graph, the first step is replace all passive elements, comma, voltage source with short circuit. So all the passive elements as well as voltage source should be replaced with a short circuit, and the second one is current source should be open circuit. So the current source should be an open circuited and voltage source should be a short circuited. Now I am converting this circuit into a graph theory. So whenever I am converting this circuit into a graph theory, as I have told you, this voltage source should be a short circuit. So here I am making this voltage source as a short circuit, and the resistor element is also a passive element, that is the reason I am short circuiting, and I am making a capacitor as a short circuit, inductor is also short circuited, resistor R2 is also short circuited, and the current source should be an open circuit. So here, if I'm seeing this graph, I can say that they are not representing what is the type of the element which is present over here. Rather than I am making use of the whether it is short circuited or open circuited. The same thing I can redraw in the other way such that all these are connected to a single line. So I am making this as one node. So all these four are connected to a single point which is nothing but a node. And from this point, that is from this voltage source, it is connected to a resistor. So here this is one node from R1 to L1. That is from this point to this point there is some resistor value over here. So I can redraw this circuit in such a way that so here, what is the representation of these dots? Here dots are nothing but nodes. When we will be saying that this is a node. So here node is nothing but intersection of two or more elements at a particular point is called as a node. So if I observe this circuit, here voltage source is at this point. Similarly, the resistor is also pointed out at the same point. That is the reason I can say that this is one node. Similarly, this is a node because here resistor, one terminal of resistor is connected and one terminal of capacitor is connected. That is intersection of two or more circuit elements at a particular point is called as a node. So from this, I can say that the first thing is node, that is intersection of two or more elements at a particular point is called as a node. So from this figure, I can say that this circuit consists of four nodes. I am representing these nodes as A, B, C, D, E. So here these A, B, C, D and E are nothing but nodes of this graph. Similarly, the line segment joining between these two nodes is nothing but called as a branch. So here what is meant by a branch is nothing but whatever the element in case of a circuit will be calling this as a resistor. So this resistor is nothing but a one branch in the graph theory. So the line segment which is joining between the nodes is called as a branch. So here in this figure it is having how many branches? 1, 2, 3, 4, 5, 6, 7. So total it consists of 7 branches and 5 nodes. If coming to the next definition, that is nothing but graph. So graph is nothing but in which it consists of branches and nodes is nothing but called as a graph. So graph is defined as collection of nodes and branches of a network is called as a graph. The next definition is subgraph. So here subgraph, sub itself indicates a part. So here in this complete graph, if you are taking any some part of a graph, so here let me assume that I am taking a part as A, B, E. So this is nothing but called as a subgraph. A part of a graph is nothing but called as a subgraph. Whether subgraph may be a closed path or an open path. A part of a graph is called as a subgraph. The next definition is loop. Here loop is nothing but it should start from one point and it should end at the same point. So here loop is nothing but in simple words we can say that a circle which is present in a closed path is nothing but called as a loop. So here I am starting from node A, then I am traveling through a path of B to E, E to A. I am starting from point A and again I am going back towards the same point of A, which is nothing but called as a loop. So these are the basic definitions of this network topology. And after loop, there is another more thing which is nothing but called as a tree. So before going for the tree, let us see how to draw one or two electrical circuits in terms of the graph theory. I am repeating these 4-5 definitions once again, and node is nothing but intersection point of an two or more elements in a graph is called as a node. The line segment joining between two nodes is called as a branch. If a network consists of nodes as well as branches, then it is called as a graph. A part of a graph is called as a subgraph. This subgraph may be either an open loop or a closed loop. Coming to the next one, which is nothing but a loop. In case of a loop, always it should start from one point and it should pass through the some other points, but the ending point of that path should be connected towards the starting point. That is, closed path is nothing but called as a loop. Now, let us see one example how to draw a given electrical circuit into a graph. So here I am assuming that it consists of some voltage source, an inductor which is a passive element, a resistor and a capacitor and other more resistor. So here I am taking these passive elements representing with some numbers like L1, R1 and C1, and let me take, there is other more capacitor resistor over here which is nothing but a R. So here inductor L, R1, C1, R2, R3 and this is a voltage source. So in order to draw this into the corresponding, here the first thing is we need to replace all the passive elements and an voltage source with a short circuit. And in simple words, from this diagram only, I can directly say that how many nodes are present. So here, as this resistor is present in between all these voltage source, capacitor and a resistor are connected to a common point. So this is one node. From this, it is connecting from voltage source towards a capacitor 1 and towards other and the resistor. So this is one node and this is the other node because here it is touching with an voltage source as well as a resistor as well as a capacitor. So node is a common point where there is an intersection of more than two elements. It is connected one element with a two passive elements followed by an active element. Similarly, this is the other node because at this point it is connected to a two resistors followed by a capacitor. And here there is a other more node in which it consists of a resistor followed by, so at this point it is connected towards a resistor as well as inductor. You cannot make this as a node because at this point it is connected with only these 2 points, that is nothing but here it is connected with a resistor itself. So in this case it consists of complete of 4 nodes, that is, so here this is node A, B, C, D, and there is an element between A and B. So this is A, B, C, D. I am least bothered about the type of the element, so I am drawing a branch. So a line segment joining between the nodes is called as a branch. This is one branch, and between B and D. This is the other branch between A and D, and between B to C, C to D, and A to C. So these are nothing but called as branches. Let me take 1, 2, 3, 4, 5, and 6. So here it consists of 4 nodes A, B, C, and D, and 6 branches 1 to 6. So this complete is nothing but this is called as a circuit, and this is called as a graph, because in case of a graph it consists of nodes as well as the branches of a circle. And the next one is subgraph. So I can take a subgraph as ABDA or ACBA, or similarly, or in simple words, I can take all these as one subgraph, or this part as a subgraph. And coming to the next one, which is nothing but a loop. So here closed part, this is starting from A to B, B to D, and D to A, is called as a loop. Now coming to the next terminology, which is nothing but tree. So the important concept of this graph theory is, if I want to find out the voltages and currents of a particular circuit using a graph theory, we must able to have a perfect idea regarding tree poetry. So here let us see the concept of a tree for the same example. Yeah. Before going for the tree, now let us see these graphs may be either oriented graph or directed graph, and the other one is unoriented. So the name itself indicates, if there is some arrow marks, that is, if there is some indications how the current is flowing from one branch towards the other node, then such a graph is called as an oriented or a directed graph. If there is no arrow marks, means if it is not specifying the flow of direction of current, such graphs are called as unoriented graphs. So for this, if I am taking, assuming that the current is flowing from A to B, B to C, A to C, similarly A to D, then such network, this graph is called as a directed graph. If there is a presence of direction of arrow marks in a graph, then it is called as a directed graph. If there is no flow of direction of currents, then it is called as an undirected graph. Now let us see for the tree. So here that a tree is nothing but, it should consist of all the nodes present in a graph. So the first property of a tree is nothing but, in this case, as it consists of 4 nodes, that is A, B, C, and D, it should consist of all the nodes of a graph, but less than the number of branches present in a graph. So in this graph, it consists of 6 branches, but whereas in case of a tree, it should consist of all the nodes of a graph, that is 4 nodes, but less than that of the 6 branches of a graph. And the other more important property of this tree is it should not have any closed path. That is, it should not make the complete part of a graph as a tree. So now let me draw the tree for this graph. So as I am specifying it as, the first point is it should consist of all the nodes, that is 4 nodes A, B, C and D. It should consist of all the nodes of a graph. The second step is it should consist of less than the number of branches of a tree. So here I need to draw a tree in such a way that it should consist of branches less than that of the 6. So there is a branch between A and B. The corresponding branch is 1. There is a branch between B and C, which is nothing but 2. And there is a branch between B and D, which is nothing but 4. So here I have covered all the branches, I have covered all the nodes of a graph, but it should consist of less than that of the number of branches of a graph. Now, if I am drawing a line between A and D, it is forming a closed loop. That is the reason it should not, I should not draw any line segment. That is, I should not draw any branch between A and D. So the first property of a tree is it should consist of all the nodes present in a graph, and the second is it should not consist of closed paths in a tree. And the third most important thing is the number of branches in a tree should be less than that of the number of branches in a graph. So this is one tree for the given graph. If I want to draw the other more tree, I can draw in such a way that A, B, C, D. I can draw directly from A to C and A to B, B to D. If I am drawing B to C, here again I will be getting a closed path. So that is the reason I should not draw any line segment or a branch between B to C. The corresponding is 1, 4 and 6. There is an importance for the direction of an arrow of a graph that represents degree of a node. Means if you want to find out what is the degree of node A. In case of the degree of node A, how many branches which are entering. So here the entering from at this point A, there is no current flowing towards A, but there is a current flowing out of A towards D as well as towards the B. So degree of node A is 0. Similarly, if you see for B, it is entering into B. Here also it is entering. So this is 1, this is 2, and it is leaving. So the degree of node B is 2. Similarly, if you see for degree of node C, 2 are entering. So degree of node C is 2. Coming to degree of node 4, 2 are entering. So here it is 2. So if you calculate and the degree of node A is A to C is leaving, A to B is also leaving, A to D is also leaving. But the degree of node over here, that is, if you calculate all these things, you should get the total branches should be is equivalent to degree of node. So here coming to that of the tree is nothing but it should have all the nodes present in a graph. It should have less than the number of branches in a graph, and it should not form any closed loop. And there should be a minimum of one path between each and every individual node. Now, coming to that of the core tree. So here core tree is nothing but whatever the branches which are not present, or in simple words, before going for the core tree, Let us see what is meant by twig. The branches of a tree is called as a twig. So in this, the branches, that is nothing but here, if you take the first tree, this is first tree, this is second tree. The branches of these tree, that is 1, 2, 4. These branches are called as twigs. Whatever the branches which are present in a tree, those are called as a twigs. So here in this case, the twigs are 1, 4, 6. So here the branches of a tree are called as a twigs. Coming to the next one, quadtree. The graph which is which constitutes with links. So here before going for the quadtree, first we should understand what is meant by a link or chord. So here in this tree, whatever the branches which are absent. So here branch 3 is not there, branch 5 is not there, branch 6 is not there. So here these branches 1, 3, 5, sorry, 3, 5, 6. 3, 5, 6 are called as links. The set of links are called as quadtree. So here all these the links are represented with a dotted line, and that is the dotted line represents the links. A group of links is called as a quadtree. Whenever you are drawing a link, then only a closed loop is formed. If there is no link, that is, if I let me take for the second tree, if I am drawing a line between A and D, it will form a closed loop. So in order to form a closed loop, there should be a branch. Whatever the branch which is used in order to make it as a closed loop, then it is called as a quadtree. So then it is called as a link. So branches of a tree, the absence of branches of a tree are called as links. The present branches of a tree are called as twigs. The group of links is nothing but called as a quadtree. This tree concept, quadtree, link and twig concepts are used in matrices of network topology, which we are going to discuss in the next session. So, we need to remember what is meant by a tree, what is meant by a twig, what is meant by a quadtree, and what is meant by a link. Depending upon these four basic definitions, we can able to find out the unknown voltages and loop currents by using an incidence matrix, die-set and cut-set matrices, which we are going to discuss in the next class.